So what we want to look at now is another way of finding the solutions of a quadratic equation, and it's what we call a method of completing the square. So to complete the square, what we need to do is remember some results, and these ones here are the ones we need to remember. A plus b all squared equals a squared plus b squared plus 2ab. And if it's a minus b all squared, it's a squared plus b squared minus 2ab. So we need to remember those two results there. Now, what we want to do is solve this quadratic equation by completing the square. Now, the idea of completing the square means that we get a perfect square. So we start with our quadratic equation. And what we don't normally do, we normally just keep it equal to 0. But for completing the square, we're going to take any constants across to the right-hand side. So move your constant to the right-hand side. So then x squared plus 3x there, we're going to want to complete the square. Now, the number that could complete the square, if we go back to this one, we see that when we have the middle term, we're always going to have this term squared plus this term squared, no matter which way we go, plus or minus here. We get the a squared plus b squared. But then it's 2 times the product of these two. So when we look at this number here, that's going to be 1. So really we're just looking at the 2 times the product of this number, the product of this number plus the 1 in front of the x, because it's 1x squared. It's just going to be 2 times this number is going to give us that number. So that's where we get the 3 on 2 from, because we take our 3 there and divide it by 2. So we get 3 on 2, and then if we expand that out, the 3 on 2 all squared will give us 9 on 4. So that's where we are able to go from this line to this line by just adding the 9 on 4. Now, remember when we add 9 on 4 on one side, we add the 9 on 4 on the other. So that's what we're doing, completing the square on the left-hand side, and we're going to add that same number to the right-hand side. So we get this equation here. Now, the idea to get about completing the square is getting x by itself, because we just can't factorize an x out here because we've got the 1 there and it's not a common factor. So we get it to a perfect square like this, and then we can take the square root of both sides. So we get the positive and negative square root of 5 over 2. And then we're going to subtract 3 on 2 on both sides, and there's our two solutions. X will be equal to minus 3 on 2 plus root 5 on 2, and minus 3 on 2 minus root 5 on 2. So we get x, and by making x the subject, by taking the 3 on 2 across. So that's how we start to complete the square. Get the number that's going to make it a perfect square, and it's related to that number halved and then all squared. And then once we've got our perfect square, take the square root and then add or subtract the number across. So let's have a look at this one this time. Again, we're going to do the same process. We've got x squared minus 6x minus 6 equals to 0. We move our constant to the right hand side. This time we're going to look at the 6, we're going to halve it and square it. That gives us our 9s. Half of minus 6 is minus 3. And we should have said before, when we complete the square, we like not having a number. We like it to be monic. So doing division if it's not monic, so it becomes a monic quadratic there. So we get that as a perfect square. We've got the 6 plus 9 is root 15. We're going to take the square root of both sides, so we get the plus and minus square root of 15. And the x minus 3 now we can add 3 on both sides, and we get 3 plus or minus square root of 15 are our two values for x. So that's what we do when we complete the square. We try and get it down to a bracket so we can take the square root of both sides, and so the idea is always to get x by itself, make it the subject. So have a look at those processes and make sure we know what we're doing when we do every line of completing the square.